Hello students, in the last two sessions, we have in detail studied how in a crystal lattice or in a crystalline solid, we arrange the particles in three-dimensional space. We have seen that when you arrange the particle in two dimensions, you get some empty space between the particles. This empty space is called as void space or simply void. In two dimension, these voids are of two types. If the arrangement is AAAA type of arrangement, then the void is a square void. But if the two-dimensional arrangement is ABAB type, then it is a triangular void. There are two types of triangular voids. One is a triangular void whose apex points upward, and the second triangular void is the one whose apex points downward. Further, we saw that when this two-dimensional arrangement is converted into three-dimensional arrangement, then these voids do not remain the same. They get converted into two different types of voids. They get converted either into tetrahedral void or octahedral void. So in this session, we will be studying about these voids which we get in three-dimensional arrangement and not in two-dimensional arrangement. So this is the third part of the concept packing of particles in crystal lattice. In this part, we will be studying about void. As I told you earlier, the empty space that results due to arrangement of spheres is called void space or void. In three-dimensional arrangement of spheres, what are the different types of voids? When the spheres are arranged in three-dimensional space, you get two types of voids as follows. Number one, tetrahedral void, and number two, octahedral void. Now what do you mean by a tetrahedral void? Suppose there are four spheres. They need not be of the same layer. They will be of different layers. If they are arranged in a tetrahedral fashion, then that void is known as tetrahedral void. So void formed due to tetrahedral arrangement of four spheres is called tetrahedral void. This tetrahedral void looks in this way. If you see the blue colored spheres, they belong to one layer and they form a triangular void in them. On this triangular void, if I place a sphere of a layer above it, then this triangular void gets hidden and the triangular void gets converted into what is called as tetrahedral void. Now the second void is octahedral void. Now if I have four spheres, not necessarily of the same layer, they may be of different layers also, and if they are arranged in an octahedral fashion, then the void that results is called as octahedral void. So void formed due to octahedral arrangement of six spheres is called octahedral void. How this octahedral void looks like? If you can see the pink color layers which are labeled as Q, O and P, they are the three voids of one particular layer. The blue voids labeled as, blue spheres labeled as N, N and R, they are the three spheres which are of a layer above the pink layer. Then if these six spheres are arranged in this manner, with the pink sphere you have a triangular void whose apex is pointing upward. And in case of blue colored spheres, you have a triangular void whose apex is pointing downwards. When these two oppositely triangular voids of two dimension lie exactly one over the other, then what you get is an octahedral void. So in three-dimensional arrangement, you get two types of voids, that is tetrahedral void and octahedral void. Now, in three-dimensional arrangement, you have HCP, that is AB-AB type of three-dimensional arrangement, or CCP, which is ABC-ABC type of three-dimensional arrangement. In these two arrangements, you have tetrahedral as well as octahedral voids. Then, per atom, how many tetrahedral voids are there and how many octahedral voids are there, that we are going to study now. In HCP and CCP arrangement, both tetrahedral as well as octahedral voids are present. It is observed that for each atom, you have two tetrahedral voids associated with it, and per atom, you have only one octahedral void associated with it. So the number of octahedral voids is half of the tetrahedral voids in the given arrangement. Suppose in the arrangement you have n number of particles, then the number of tetrahedral voids will be double, that is 2n, and the number of octahedral voids will be same, that is n. So in HCP and CCP arrangement, if number of particles are n, then the number of tetrahedral voids are 2n and number of octahedral voids are n. Let us take a simple problem based on this concept. See the problem. There is a compound which is made up of elements C and D. When the particles of elements C and D are arranged, the arrangement is found to be FCC. FCC, remember, is similar to CCP. In this arrangement, it is observed that atoms of element C are present at the corners, whereas atoms of element D are present at the center of the faces of the cube. With this information, we are supposed to find out what is the formula of the compound. See how to solve this problem. It is given that C atoms are present at the 8 corners of the cube. We also know that contribution of each corner atom to the unit cell is 1 by 8. Therefore, the number of C atoms belonging to the unit cell is 1 by 8 into 8, that is 1. It is given that D atoms are present at the 6 face centers of the cube. We also know that contribution of each face centered atom to the unit cell is 1/2. Therefore, number of D atoms that belongs to the unit cell is 1/2 into 6, that is equal to 3. So per unit cell, the number of C atoms is 1 and number of D atoms is 3. Thus, the formula of the compound is CD3. Such a simple numerical can be asked on this particular part. Let us take another numerical. There is a compound. It is formed by two elements A and B. It is observed that the atoms of element B forms CCP structure, whereas the atoms of element A are present in the tetrahedral void and they occupy only 1/3 of the tetrahedral void. Means all the tetrahedral voids are not occupied by the atoms of element A. 1/3 will be occupied and the remaining 2/3 will be empty. With this information, now I have to find out what is the formula of the compound. See the solution. Which atoms form CCP structure? Atoms of element B forms CCP structure. Let the number of atoms be exactly B. Because of the arrangement of B atoms, tetrahedral voids are generated. How many tetrahedral voids are generated? Twice the number of B atoms. So, the number of tetrahedral voids generated will be 2B. Now, atoms of elements A occupy one-third of tetrahedral voids. Means number of atoms A will be one-third of 2B because tetrahedral voids are 2B. So it will be 2/3 B. Now I'll take the ratio of number of atoms of A and B. It is 2 upon 3. B is the number of atoms of A and B is the number of atoms of B. So it will be 2/3. So the formula of the compound is found to be A2B3. So from the knowledge of the position of the atoms in the three-dimensional structure, you can easily determine what will be the probable formula of an given compound.
Thank you. Please like, comment and subscribe for the further videos.